So I have given you a test of some C1 stuff and some S1 stuff, and these are the results. So these 4 people got pretty rubbish results, to be honest. But anyway, then I look at the results and I look at the test and I think, do you know what? This is after I've done all my work. I've done all the 6 ingredients for, let's call them C for C1 and S for S1. I've done all the 6 ingredients. I've done all the 3 mixtures. I've worked out the PMCC. I've worked out the regression line of maybe S on C, something like that. And then I think, do you know what? That C1 test was a bit hard. I'm going to give everyone an extra 10 points on that because I think that's fair. So I'll have a new variable. Instead of C, maybe I'll call it, I don't know, X. And X is going to be C plus 10. So everybody gets an extra 10 points. So this is 52 and this is 78, etc., etc. And I can't add on 10. 42, 60, anyway, you know what I mean, add on 10. So, do I have to start all over again? Do I have to actually do now the new 6 ingredients, the new 3 mixtures, the new PMCC, the new regression line? No, I don't. So this is how we change what we did before to get the new PMCC and the new mixtures and the new regression line. Firstly, good news, the PMCC will not change. So if you worked out that the PMCC of X on Y, of X and Y together, if that is 0.78, then the PMCC of our new variables, P and T, is 0.78. So you'll see this in the exam. This is worth 1 mark because the PMCC doesn't change, so it's exactly the same. Hooray! Unfortunately, other things do change. So the 2 main mixtures, SXX and SYY, they will change. But they change in the same way as when you've done coding with discrete random variables. So if you had the variance of 5x minus 20, you know that that would be 25 times the variance of x. You ignore the minus 20 and you multiply by the 5 squared. The variance of 6y add 10, you know that would be 36 times the variance of y. We ignore that 10 and we times by the 6 squared. Same thing here, this is how it works with this, because it's a bit like variance, the SXX formula. So if SXX is 218, then then SPP is going to be 25 times 218. And that 25 is the 5 squared. And SYY, we know that T is going to be 6y plus 10. So the 10 is irrelevant, it's the 6 that's relevant. STT will be 36 times SYY. So that will be 36 times 41. It's ever so easy to find the new regression line. We literally just take this information and put it in to the regression line. So the P information goes in here and the T in there. So we'd get 6y add 10, that's T, equals 0.718 minus 2.14p, which is 5x minus 20. And then you just expand that out. 6y plus 10 equals 0.718 minus, calculator, 2.14 times 5. Oh, I should have been able to do that. 10.7 plus, I probably should be able to do this as well. 42, oh, I forgot my x, 42.8, and then just collect everything together, so it says y equals. So 6y would equal 0.718 add 42.8 minus 10, 33.518. I think I'm doing this right. Minus, well, I am doing it right mathematically, but I may have added up wrong. And then divide everything by 6. So y, I'll write this at the top because I've run out of room. Y equals 33.518 divided by 6. And 3 significant figures, don't forget. So 5.59 and then minus 10.7 divided by 6, 1.78. So minus 1.78x. So we've gone from the original regression line of T on P to the new regression line of Y on X. Very simple. See if you can do these yourself. Pause the video. We've got the original PMCC here, the original regression line of Y on X here. We've got the original two main mixtures, SXX and SYY here, and we've got this coding. Y is changing to 46 minus 20m, X is changing to 50 plus 15p. See if you can state the new PMCC, you really should be able to do that, the new SPP and the new SMM using the old ones, remembering that it's like discrete random variables with variance, and the new regression line, which is where you write down the old regression line, sub in the changed variables and then tidy it up. See if you can do it yourself and then unpause the video and look at the answers. Okay, first one, no one should have had a problem with this. The old PMCC is 0.78, PMC doesn't change, so the PMCC between M and P is 0.78. Easy. Still pretty easy this. SPP, or X, is P times 15 add 50, and we don't care about the add 50. It's not relevant for us at the moment because we're doing it like a variance. So it's the 15 that matters. So the SPP will be 15 squared times SXX. So that's 2310 times 15 squared is a huge number, 519750. And the SMM, well, we can see here that M has been multiplied by minus 20. We're not interested in the 46, that doesn't make any difference to us. M has been multiplied by minus 20, so minus and a minus makes a plus, so I don't need to bother with that. 20 squared times the original SYY, so that's 20 squared times 10058, which is huge. That number there. Okay, this is probably the one with the most work. We've got the original regression line now. We're going to change Y to 46 minus 20m, and we're going to change X to 50 add 15p. So expanding this out, 46 minus 20m is 4.1 plus 278 times 50 is 13900 plus 278 times 15 is 4170p. Collecting all those numbers together, minus 20m is 4.1 add 13900 minus 46, 13858.1. And then on the end we've got our 4170p. And then dividing everything by minus 20, m equals that divided by 20 is minus 692.905, and then minus 4170 divided by 20, 208.5p. But the final answer, we always give it to three significant figures, so it would be minus 693 minus 209p, using three significant figures for the intercept and three significant figures for the gradient.